Hi everyone, it's Elliot from TutorialEdge.net, and in this tutorial we're going to be looking at how you can deploy a resilient Go application to DigitalOcean's Kubernetes service. So let's go over what we're going to cover in this tutorial. First of all, we're going to develop a really simple Hello World application in Go. We're then going to look at how we can containerize that application using Docker. We're then going to spin up a really simple Kubernetes cluster using DigitalOcean. And finally, we're going to deploy our newly containerized Go application to this cluster. Now, before we get started, you're going to need the following. So you're going to need Go installed on your machine. You're also going to need Docker installed on your machine, as well as the kubectl CLI installed on your machine. Now, the text version of this tutorial, which is on DigitalOcean, will have all the instructions in order to install these tools, and I'll leave a link in the description below. With all that out of the way, let's get coding. Now I'm going to jump into Visual Studio Code, which is my code editor of choice for writing Go applications, and I'm going to start off by creating a really simple main.go file. Now this is going to be package main. I'm then going to define my list of imports, so we want the FMT and the net/HTTP packages, and below this we're going to want to create three distinct functions. So we're going to create a homepage function, which is going to be the function that handles any incoming requests. We're also going to want a setup routes function, which will map these requests to this homepage function. And finally, we want a main function, which is going to be the main entry point to our Go application. So let's start off with that homepage function. So homepage, which will take in a response writer and a pointer to a HTTP request, like so. And this is simply going to do fmt.f printf to the response writer, my awesome Go application or app. Cool. Next, let's do that setup routes function. So setup routes. And this is just going to use http.handle func. And it's going to map the homepage or the / root of our application to the homepage function, like so. And finally, let's define our main function. So func main fmt.println, and we're going to say something helpful like Go web app started on port 3000. We're then going to call our setup routes function. And finally, we want to tell our Go application to listen and serve on a given port. So http.listen and serve. And we're going to serve this on port 3000 and passing in nil as the last parameter. Awesome. So let's test all of this works by jumping into the terminal and running go run main.go. We should see that our Go web application has been successfully started on this port 3000. And if we jump into our browser and hit this application, just make this bigger, you should see that it has successfully mapped my incoming request to the homepage function, which has in turn returned my awesome Go app to the browser. Perfect. So now that we have a really simple Go application that runs on port 3000, let's go ahead and try and containerize that using Docker. So I'm going to come back into Visual Studio Code, and I'm going to start off by creating a new file called Docker file at the root of my project. Now, within this Docker file, we're going to specify a couple of things. So we're going to specify the base image, and then we're going to specify some of the commands in order to build and then subsequently run our application. So let's start off with the base image, which is going to be Golang 1.12.0, and we're going to use a nice light Alpine 3.9 image. Next, we're going to want to do the following. So we're going to want to do run make their app, which is going to create a directory called app within our container. We're then going to want to add all of our source files or all of our project contents to this app directory using the add command. We're then going to want to specify that our current working directory is within that app directory. And then we're going to want to specify the build command. So go build -o main, and we're going to want to pass in the current path. And then finally, in order to kick off our application within this Docker file or within this Docker image, we want to specify command and that's going to simply run the executable that we've created within the previous step, and that's going to be found in app and main, like so. Now, this certainly isn't the most optimized way of building a Docker image for your Go application, but it serves its purpose within this tutorial as it gets us up and running really quickly, whilst keeping the complexity low. Now, if you're interested in making a far more lightweight Docker image for your application, then I recommend you check out my next tutorial, which is going to be on building multi-stage Docker files for your Go application development. Now, let's go ahead and build our Docker image from this Docker file using the docker build command. So if I come into my terminal and I do docker build -t, and I'm going to say /go web application, and I'm going to pass in the current path. That's going to go ahead and run through all of the steps defined within our Docker file, and it's going to successfully create our image for us. Now, if I then look at the images on my machine and I search for just /go web application, I should be able to see my new image that is now available within our machine. Now that we have successfully created this image, let's go ahead and try and run this image as a container on our local machine using the docker run command. Now, coming into my terminal, I'm going to do docker run it, and I'm going to map the ports of 3000 on my local machine to 3000, which is the port that our application will be running on within the container. And I'm then going to specify the /go web application image name. Now, that's going to go ahead and start our application within a container. And again, if we open up our browser and hit the same localhost 3000 URL, we should still be able to see our application, except this time it is running within a container. Awesome. So we've been able to validate that the Docker image that we've created can be successfully run within a container on our local machine. Now, the next step is to push this Docker image that we've created up to a public repository so that we can later pull it down and deploy it as an application or within a container in our Kubernetes cluster in the next step. Now, in order to push this up to Docker Hub, we're going to want to use the Docker CLI. We're going to want to log in using the credentials from Docker Hub. And we're then going to want to Docker push and the name of our image, so Go web application, like so. That'll go away and push everything up to Docker Hub for us to then view later on. Coming back to it, now that this Docker push command has finished, I should then be able to go into Docker Hub and I should be able to see my newly created image available for everyone else to consume. Now, with everything in place and our Docker image is now available for public consumption, we can then move on to creating our Kubernetes cluster and subsequently deploying this new image to our cluster. So I'm going to open up the DigitalOcean control panel. I'm going to hit Kubernetes and I'm going to click Create a new Kubernetes cluster. Now, when provisioning this Kubernetes cluster, I'm going to keep the Kubernetes version just as is. I'm going to select London as my local data center, and I'm going to leave everything else just as it is, and I'm going to click the Create Cluster button. Now, that's going to go away and provision my Kubernetes cluster for me. Now, the important part here is to next download the config file, which we can use in order to interact with this newly provisioned Kubernetes cluster. So I've now moved this kubeconfig file.yaml into my current working directory. Now, by default, when you run commands with the kubectl command line tool, you have to specify the path of the cluster configuration file using the --" kubeconfig flag. However, if you store this configuration file as config within the .kube directory on your machine, kubectl will know where to look for that configuration file and will be able to pick it up without needing the --" kubeconfig flag provided to it. Now, this is really handy as it saves you typing out a lot of --" kubeconfig arguments within your commands. Now, in order to move this, I'm going to then use the move command. I'm going to take my current file and I'm going to move it to that .kube/config location. With this being done, you'll see it's no longer in our current working directory. I can close this and I can test to see if this works. So kubectl get nodes, and I should be able to see all of the 3 nodes available within my newly provisioned Kubernetes cluster. So at this point, we've got a containerized application and we've got a fully functioning Kubernetes cluster that we can deploy this application to. The final piece of the puzzle is creating a deployment and subsequently a service that will both deploy and expose our application to the outside world. Now, we're going to start off by creating a Kubernetes deployment.yaml file. Now, this deployment.yaml file will define a Kubernetes object known as a deployment. And this deployment is going to be effectively a grouping of multiple pods. Now, a pod, for reference, is a group of 1 or more containers which are able to communicate over the same shared network and interact with the same shared storage. Now, the deployment is a way of managing all of these pods together. So say we wanted to run 5 instances or 5 pods which contain our application on the same Kubernetes cluster, we could do that within this deployment.yaml file. Cool, so I'm going to create a new file within my project and I'm going to call this deployment.yaml. Oops. And within this, I'm going to define the following. So I'm going to start off by defining the API version that we wish to use, which is apps. Oops. And I'm going to specify the kind that I'm defining within this deployment.yaml, which is going to be deployment. Now, below this, we're going to want to then define the metadata for our Kubernetes object. Now, the metadata field is required for every Kubernetes object as it contains information such as the unique name of that object. Now, this is really helpful for us as we can give this the name of Go Web Application. But imagine you were deploying, say, a test application and a production application within the same Kubernetes cluster. You could then specify the different names within this field. But for now, let's keep it nice and simple and call it Go Web Application. Below this metadata, we then want to define the spec of our deployment. So spec, and within the spec, we can say things like the number of replicas we wish to deploy. So I'm going to keep this as 5. And we can then define the selector block. So this is going to match labels and name Go Web App. Below the selector, we then want to define the template. And again, we're going to have another metadata block within here. And we're going to say labels, name, Go Web App. And finally, we're going to want to define the spec block within our template block. So one in underneath here. Within this spec block, we want to define the following. So containers, and the name, which we're just going to keep as application. We're going to want to define the image that we're going to be pulling down, which is going to correspond to the name that we pushed up to Docker Hub in the previous step. So Go Web Application. And we're going to define an image pull policy. So image pull policy, if not present. And the ports that our application is going to run on within our container. So container 3000. Now let's break this down and describe exactly what we've done here. So within this section here, we've defined the match labels field. Now essentially this field tells Kubernetes what pods the deployment applies to. And in this example, we've told the deployment will apply to any pods with the name Go Web App. Now, below our selector field, we've defined the template block. Now, every deployment within Kubernetes creates a set of pods using the labels specified within our template block. The first subfield is the metadata, which contains the labels that will be applied to all of the pods within this deployment. These labels are effectively key value pairs that are used to identify attributes of Kubernetes objects. When you define your service later on, you can specify that you want all of the pods with this name label to be grouped under that given service. And again, the spec block basically just tells our deployment what it's deploying. So it tells it where to go for the image, and it tells us things like the ports that it's running on and the pull policy if it can't find that image locally. So now that we've defined this, the next step is to actually create this deployment or apply this deployment. Now, if we come back into our terminal, we can use the kubectl command line tool, and we can say apply -f deployment.yaml. Now, if we've done everything correctly, that'll go away and it will create this deployment object within our cluster, and we'll then be able to see this using kubectl get deployments, like so. As you can see, we've just created this deployment, so none of the images or the containers are ready, and you can see things like the age of our deployment. So if I give that just a little bit of time and then rerun the get deployments command, I should be able to see that all 5 of my pods within my deployment are now up and running. Awesome. So at this point, we've actually been able to deploy our containerized Go application up to our Kubernetes cluster. But the next step is to define a way of accessing this newly deployed application. Now we can do that through creating a service. So I'm going to create a new service.yaml file. And much like I did with the deployment, I'm going to specify things like the API version I want to use, which is just v1 in this case. I'm going to specify the kind, which will be service. And again, we want to specify that metadata field and give it a name, Go Web Service, like so. Now, below this metadata block, I want to define the spec for this deployment. Within this spec block, I want to define the type of this service, which will be type load balancer. I then want to define the ports for this load balancer. So I'm going to give this first port a name of HTTP. I'm going to say the port that I want to expose my application over is port 80. And I'm going to say the target port is 3000, which is the port running our application within a container or within a pod. Next, below this, I want to define the selector. So this selector block is important as it maps any deployed pods named Go Web App to this given service. So selector, name, and Go Web App. Perfect. Now, after saving this, the final step is to apply this service.yaml file. So coming back into the terminal, I'm going to do kubectl apply -f and service.yaml this time. That's going to go away and take this service.yaml spec and create the web service for us within Kubernetes. Now I can then run kubectl get services, and I should be able to see that my new service has just been created. And at this point, the external IP address at which I can access my application is still being created. So I'm going to come back to that in just a couple of minutes. Awesome, so coming back to that a few minutes later, I'm going to run this kubectl get services command again. And at this point, I should see that my external IP address is no longer pending, and it has been set to 67.207.70.210. I can copy that, and I can open up my browser. And if I put that IP address into my browser, I should see that my awesome Go app has been returned. Now, this is pretty awesome. So we've been able to successfully containerize our Go application and then subsequently deploy it to a 3-node Kubernetes cluster over 5 replicas and provision a load balancer on top of these replicas so that any incoming requests are round robined equally over the 5 instances of our application running within the cluster. Now, hopefully this has given you some indication as to how you can go ahead and deploy your own resilient Go applications to a Kubernetes cluster. I really hope you've enjoyed this fairly lengthy tutorial. If you have, then please let me know in the comment section below. Please like my video to give me a wee bit of support, and subscribe to my channel for more programming content. Cheers!